Guys, hope all of you are doing great. Today we're going to look at acids and bases, and this basically is going to be a short concept that is going to assist us identify acids and bases and appreciate their roles in trying to identify other chemicals in chemistry. This is a basic topic, of course, that we're going to look into, particularly concerning its definition and its implication on how we can be able to identify acids and bases. Now, there are several definitions which have been used to identify acids and bases, particularly on the aspect of trying to look at their particular characteristics insofar as the chemical and physical properties are concerned. But we're going to see that from this particular definition for acids and bases, it's going to shed a light on how we can be able to identify them. Now, in this particular aspect for the physical properties, we had mentioned earlier from our basic discussion on chemistry that for acids, we can be able to identify them using various ways. And one of them is that they have depending on their strength, they have a corrosive nature, whether it is a strong acid or not. And basically for bases as well, they can have this particular property, basic, or whether it's a substance, is a base, of course, just use this one. A base, therefore, it's going to also have some kind of a corrosive property to some extent. If we try to look at their other physical properties, we can say this one has some kind of a characteristic called litmus, whereby it changes the blue litmus to red, whereas the reverse happens for this, whereas it changes the red litmus paper to blue, to blue for bases respectively. Now, some of these physical properties, of course, might not be of assistance or will have a limiting effect if the properties of the acids and bases, perhaps the physical ones, are going to be slightly similar. Like a clear substance, we cannot be able to identify whether it's an acid or base unless we subject it to some test. So basically, there are some areas also which are going to have a confusion whenever we are trying to figure out whether a substance is an acid or a base. Therefore, there are different individuals who came up with specific definitions to try and identify whether a substance is an acid or not. So we're going to look at two examples of those, and one of them is Arrhenius. So in this particular sense, Arrhenius came up with a definition of what we can be able to refer to as an acid or a base. And according to Arrhenius, an acid is a substance that only gave hydrogen ions as the only cations in aqueous solutions. So this is the Arrhenius definition of an acid as the only as a substance that gave only hydrogen ions as the only positive ions in aqueous solutions. Now, suppose I have an example of a substance like magnesium, which is an aqueous in an aqueous solution. Of course, this is going to dissociate to form ions, which is a magnesium ions, of course, which are going to be aqueous. So therefore, if I or let me just give it as an example of this. This is magnesium as a substance which is going to be in solution form, therefore form magnesium aqueous, which basically implies that it is a solution. So therefore, if you try to look at the nature of ions in this particular kind of a solution for magnesium ions, we're going to see that it's going to contain positive ions for magnesium, 2 positive, and then it's going to contain hydrogen ions since it's in aqueous solution. So therefore, it's also going to consist of the OH ions. So this is going to be negative charges as the only negative charge in this particular case. And we're going to see that in this particular solution, it cannot fall for Arrhenius definition of an acid since the hydrogen ions are also accompanied by the magnesium ion in this particular case. of this solution of magnesium. So therefore, there are some areas or other definitions that we're going to consider, which are going to give us a clue of how this particular substance can be defined as either an acid or a base. So for Arrhenius as well, there was another definition for a base, whereby it defined a base as a substance that produces the OH. So a substance that produces OH as the only negative ion, as the only negative anion in that particular solution, therefore was defined as a base. So in this case also we are going to consider other substances which, just similarly as we have looked at the case of magnesium, and consider substance whether it can fall under the category of Arrhenius, a base or not. So therefore, Arrhenius was accompanied by another of course, who defined the concept of an acid base, and we're going to look at the Bronsted and the Thomas Lowry, the Bronsted and of course Thomas Lowry's. This is Thomas Lowry's definition of an acid and a base respect. So basically, according to Bronsted and Thomas Lowry, they give a different version of the definition of an acid and a base, and their statement, of course, was just a summary of just what we're going to give. So this is a Bronsted and Thomas Lowry's definition of an acid and a base. So they said that an acid basically is a substance that is an acid, or an acid is a substance that we can define as a proton donor, while a base is a substance that we can define as a proton acceptor. So in this case, for the case of a donor and acceptor, we're going to just have a general illustration using a reversible reaction, where we're going to identify from Bronsted and Lowry whether it's an acid or a base. So I'm going to have this reaction being given as this is a substance that is undergoing a reversible reaction, Cn, and that is going to form the hydrogen ion at that specific point. So therefore, if you try to look at this specific reaction, this is going to be aqueous solution. This is a liquid for water, and then we're going to have an aqueous solution. This one is our charges, so therefore it's going to form that specific part. So if you try to look at this particular case, we're going to consider whether they are, according to Bronsted and Lowry, whether one substance is a proton donor or acceptor. And therefore, we're going to see that from this particular case, we can be able to just identify the Bronsted acid. Now, if you look at this particular part for the reaction side, or the reacting species, and the transformation from this particular gas to this ion, we're going to see that it's going to lose a proton or a hydrogen charge, therefore which is going to be transferred and form that particular case a hydronium ion. Therefore it's donating this particular proton to the hydronium ion. Therefore it can qualify to be Bronsted Lowry or a Bronsted acid, and it has donated this specific ion. Therefore this is going to form a Bronsted base. So in this reaction side, it is donating this hydrogen ion to form this particular case. So it is donating this hydrogen ion to this particular compound. So this arrow is just indicating the formation of this resultant ion from this particular case. So therefore this hydrogen ion is going to be donated to this water molecule in order to form a hydronium ion. Therefore from the reacting side, we can be able to conclude that this is a Bronsted acid and this is a Bronsted base respectively. But from the reactant side, we're going to see that by that definition, a base is a prostate acceptor. And if we try to look at this, we're going to consider the aspect of a forward and a backward reaction. Therefore, in the reaction, we're going to see that this particular species and water are going to be a prostate acid and a base from the forward reaction respectively. And whereas this particular ion, which is a Cn negative, and the hydronium ions are going to be a prostate base and acid respectively for the backward reaction. So in this case, I'm just referring to this particular kind of direction for the forward reaction. We're going to consider this one as a prostate acid and prostate base as per the definition of a prostate and Thomas-Lowry respectively. So if we consider the backward reaction, therefore we're going to see that the Cn negative and the hydronium ion are going to be considered to be the base, prostate base and prostate acid for the backward reaction respectively. So if we try to look at this, therefore, we can be able to conclude that this particular reacting species and the Cn negative, therefore, are going to be the acid conjugate base. And I'm going to illustrate this one. We have said that this is going to be the base and acid for the backward reaction, and this is going to be the acid and the base for the forward reaction. So if you try to look at this particular ion, and then this one, this from the forward reaction forming the product, and therefore we are going to consider this pair to be the prostate acid and base conjugates, and therefore we are also going to consider the water and the hydronium ion to be the prostate base and acid respectively. So this aspect of conjugate bases and ions is defined by substances that differ by one proton in a given reaction. So if we try to consider this particular case for the water and the hydronium ion, the difference basically is one proton, which of course I've indicated. This in reference to a proton, it refers to a H positive. So the difference between this one and this one is a H positive. The difference between this one and this one is a H positive. So this particular pair of substances which are having a difference of one ion are referred to as a conjugate acid-base pair. So in this case, the first one and the second one is a conjugate base pair, acid-base pair, and this water molecule and hydronium ion are a conjugate acid-base pair respectively. So in any case, if we are asked to identify the conjugate base acid pair, then therefore it's going to be easier for us from this particular illustration. So next we're going to look at another definition. Having talked about the Arrhenius definition of an acid base and the Bronsted and Thomas-Lowry definition of an acid and a base, we're going to look at the Lewis definition of an acid base, which is basically going together for all the systems, or rather identification for majority of the substances that we're going to consider either to fall under the category of an acid and a base. And this is the Lewis definition of an acid and a base. Now, according to Lewis, Lewis proposed a definition that applies to all systems, as I've said, irrespective of whether there's a presence of the proton or not in a reaction. And according to him, of course, the acid is an electron pair acceptor. So for Lewis, the acid is an electron pair acceptor. We had talked about the lone pair of electrons in reactions, previous reactions and discussion that we had done. And of course, according to Lewis, therefore the base is an electron pair donor. Electron pair donor. And if we consider the case of a substance like the ammonia that is going to react, of course, with a proton or an acidic substance or a Lewis acid, then therefore this is going to form an ammonium ion, which is an NH positive. Then if we try to consider from this particular case, a Lewis acid is an electron pair acceptor. Now the one that is donating an electron is the ammonia, and the acceptor therefore is this particular acid. So therefore we can be able to classify this reacting species as a Lewis base, which is donating a lone pair of electron, or a pair of electron, whereas the one that is accepting this pair of electron is known as a Lewis acid. Therefore, from this particular definition, we can be able to identify a Lewis base and a Lewis acid, respectively. Now, suppose this particular substance is another one. Let's consider the case of a substance. Not a substance. Okay, let's consider the case of a substance. Just going to use a compressed structure for this ammonia because of space. So let's consider a substance like that one that is reacting with trifluoro, like that. So therefore we're going to have this substance represented as NB together with this particular case for H. It's going to be H, and therefore H, F, and this is H. Let's try to look at that specific reaction. Now for the product side, we're going to just have a confirmation for this. But if we try to consider the case for the first one that we had done for a Lewis base, trying to give a specific example for this, and we're going to see that this basically is going to be, not a separation here, this is going to be this one. So this is going to be a fluoro. So therefore we're going to look at this and identify which substance is an electron pair acceptor and electron pair donor. Therefore, this is going to fall under the Lewis base and Lewis acid, respectively. So from these different types of definition we have seen for acids and bases, of course we're going to consider substances either in physical and organic chemistry and try to see which falls under the category of a base or an acid. And this is going to assist us in trying to, of course, try to identify substances insofar as their hydrogen potential and pH scale is concerned. So next we're going to look at the concept of amphoterism, which is basically going to assist us identify substances that portrays both the acidic and the basic properties, etc. So that is it for now, guys. Thank you for being with me in this lesson. I'd like to kindly request us to go to YouTube and search Honest Sciences and Mathematics TV channel. Subscribe to our channel and engage us on the comment section so that we can be able to assist one another. Also check on our description boxes for a link for other videos which are either related to this or fall under the category of maths, physics, chemistry and biology, so that we can be able to check on them. So that is it for now, guys. Bye. God bless you.